Hey everybody, so in this section 8.1 we are going to review some information about polynomials. None of this information should be new to you, it should all be review. So let's go ahead and start with some review of vocab. I think this is the easiest thing to forget about, so let's go over that first. Okay. All right, so the first thing we want to talk about is descending order. Okay, so the first thing we say is that a polynomial is in descending order if the exponents in each term are going down. For example, we might have something like 3x to the fourth plus 2x cubed minus 5x squared plus 6x plus 7. Okay, you can see that this is going down because the exponents are 4, 3, 2, 1, and then 0. Okay, you don't have to have them all. So for example, if you just have something like this is also descending order. So whatever terms you do have, you just want the exponents to descend. Okay. Okay, so now that we've talked about what it means to say descending order, this is the order that you would normally put your polynomials in, and I'm going to have you guys put your polynomials in this order unless there is a reason to do otherwise, okay? So for example, if it says factor, obviously you're not going to be writing your terms like this because that's not the factored form, right? If we're talking about a parabola and it says put it in vertex form, obviously you're not going to be writing it like this because that's not vertex form, right? But if it's just a random polynomial with the terms all multiplied out like this anyway, you do want to write them in descending order. Okay, so let's talk about the names for some of these. Okay, so the leading term is the first term in descending order, right? The leading term. And it is the term with the largest exponent, right? That's why it's going first in the descending order, okay? So the coefficient of this leading term is called the leading coefficient. Okay. All right. And then let's talk about one more thing. Oh, we have a couple more things, but one more vocab word. Okay, so the degree of a polynomial, specifically of a polynomial that only has one variable, is the largest exponent of that variable. Okay, you will also see that it is the exponent on the leading term, right? Because again, the leading term has the largest exponent. The leading term is very important. That's why there's so many names and things that refer to this first term, right? It's a leading term, its coefficient is called the leading coefficient, and its degree is called the degree overall of the polynomial. Okay? All right. Now, there's one more set of vocab words that go with polynomials. Okay? And that's that you can classify them by the number of terms. Okay? So if you have one term, this is called a monomial. Okay? If you have two terms, this is a binomial. Three terms, this is a trinomial. Okay, four terms or more, there's no special name for this. Okay, now all of these things are still polynomials. Okay, it's not like these aren't polynomials because they have a more specific name, right? These are all still polynomials, right? It would be like saying, oh, this is a Californian, an Oregonian, an Arizonian. Well, they're all still Americans, right? It's just that they have more specific names that refer to the states. That's kind of the situation here. These have specific names that refer to the number of terms, but they are still polynomials. Okay? All right. Let's look at an example of classifying polynomials in these ways. Okay, so I'm going to try to make it so you can see as much of this at the same time as possible, but I don't know how much you're actually going to be able to see. Okay, so we're talking about this polynomial, okay, and we want to give the leading term, okay. Well, the leading term is going to be the one with the largest degree, which is this one. So the leading term is 5x squared. Okay. The leading coefficient is going to be the coefficient from this term, so 5. Okay. The degree of that polynomial is the largest exponent, which is 2. You will notice that that is also the exponent from the leading term. Okay. Now, how many terms are there? We can see that there's 1, 2, 3 terms. Okay, so that makes this a trinomial. Okay, so that's how we're going to go ahead and fill this out for each of these polynomials. So here's one more normal one. We can see that the leading term is x to the 5th. Okay, now what's the leading coefficient when you don't see a number out here? That means the leading coefficient is 1. Okay, the degree is the highest exponent, also the degree of the leading term, which is 5. Okay, the number of terms, 1, 2. Okay, and what does that make this? It's a binomial. Okay. All right. Here, my leading term is going to be 4x. The coefficient on that term is 4. Okay. Now, for the degree, you have to remember what the exponent is when you don't see an exponent, right? So when you don't see an exponent at all, that degree is 1. Okay. The number of terms, 1, 2. Okay, so again, that makes this a binomial. All right, now let's look at some stranger examples. Okay, so if we just have x, if you only have one term, that term is the leading term. Okay, all right, so what is the leading coefficient? Well, the coefficient here when you don't see one is 1. Similarly, the degree, which is the exponent when you don't see it, is 1. Okay, how many terms on there? Well, there's just one term. Okay, and what does that make it? This is a monomial. Okay. All right. Now, what about just 2? Remember, this first column is the leading term. Okay, so again, if there's only one term, that term is the leading term. What's the coefficient? Well, the coefficient is the numerical value of that term, so it is 2. Okay. The degree. Okay, so that's what this is asking. Okay, the degree here, because there's no x, is 0. The degree of any constant number is 0. Okay, the number of terms. Okay, so the number of terms is 1, which makes it a monomial. Okay, and maybe the most confusing polynomial of all, which is just the number 0. Okay, so the leading term, again, if there's only one term, that is the leading term. The leading coefficient is the numerical part, which is 0. Okay. The degree, when there's no x at all, the degree is 0, right? For any number, the degree is 0. How many terms are there? 1, and that makes it a monomial. Okay. All right. So the only other thing that I wanted to review in this section, okay, you guys will see in the homework that there's a review of adding and subtracting polynomials. Okay, I'm sure you guys know how to do that. But the only other thing we're going to review is how to multiply polynomials. Okay. So let's look at something with just a monomial first. Okay. So remember, when you are multiplying something like this, you are just going to distribute. Okay. So 5x cubed times 2x squared is going to be 10x to the 5th. Right? Then when we multiply here, we're going to get negative 15x to the 4th. And when we multiply here, we will get 20x cubed. Okay. And this type of distribution is the template for all other polynomial multiplication. Okay, so let's look at a bigger example. Okay, so we're going to take the first term and we're going to multiply it out. So I get 2x times 5x squared, so that's going to be 10x cubed. Okay, then 2x times negative 7x, which is negative 14x squared. Okay, and then 2 times 2x, so 4x. Okay. Then I'm going to distribute my negative 3. So here I'm going to get negative 15x squared. Okay. Here I'm going to get positive 21x. Okay. And then here I'm going to get negative 6. Okay. So now I'm going to look for common terms. Well, I only have one cube term, so this is going to be 10x cubed. Okay. Then I'm looking for squared terms. So here's a square and here's a square. Okay, so I have minus 14 and minus 15. So this is going to be minus 29x squared. Okay, then I'm looking for x terms. So I see 4x and 21x. Okay, so this is going to be 25x. Okay, and then there's only one constant term. Okay, so you just distribute it out and then combine like terms. That's really all there is to multiplying polynomials. I just want to do one more example, and this is maybe the biggest mistake that I see when I watch students do stuff like this. Okay, so when you have something like this, what you need to do is write this out. Okay, and then multiply it out one at a time. Okay, so I'm going to go 2x times 2x, so that would be 4x squared. Then 2x times -1, that's -2x. -1 times 2x, -2x. -1 times -1, that's +1. Okay, and then I'm going to combine my like terms. Okay, now I'm going to multiply this out. You can distribute this however you want. I think it's a little bit easier somehow to distribute it this way. Okay, so 2x times 4x squared is 8x cubed. Okay, then 2x times -4x is -8x squared. 2x times 1 is 2x. Okay, and then I'm going to distribute my other terms. Okay, so I have -1 times 4x squared, which is -4x squared. Then I have -1 times -4x, which is +4x. And then I have -1 times 1, which is -1. Okay, so again, now I'm looking for like terms, so there's only one cube term. Okay, then I'm looking for squares. Well, here's a square term, and here's a square term. So this is going to give me -12x squared. Okay, then I'm looking for x terms. Here's one and here's one. So this is going to be +6x. Okay, and then I only have one constant term, so I get -1. Okay. All right. I just wanted to show you how to do this because one, sometimes students aren't sure what to do when there's 3. You just multiply 2 of them together and then you do the other one. Okay, but the other thing that I wanted to tell you is that you absolutely cannot say that 2x minus 1 cubed is the same as 2x cubed minus 1 cubed, which is 8x cubed minus 1. Okay, you can see that these are not the same. Okay, so this is not true. You absolutely can't use this method to cube something or square it or any other power. Okay, so you really need to write it out and multiply it down. Okay, all right, I hope that refreshes your memory about polynomials, and I will see you guys soon.